Hey to Algebra, Mr. Berta here. We're going to continue on with our lesson by doing 3 practice problems. The first one here, I want you to just follow along, and the second 2, I want you to try yourself first and then check your work. So we're going to look at this expression first, and please follow along as I first factor both the numerator and denominator to get it in simplified form. Okay, let's look at problem 2 here. I'm going to first focus on factoring the numerator. And one of my first questions I ask myself is there a greatest common factor that I can factor out? And what's that sound? That was the G, C, and F chords of a guitar. So there is a greatest common factor in the numerator here. And I see that each of the 3 leading coefficients is divisible by 3. And I also see that each of the 3 variables is at least x cubed. So I know I can take out a 3x cubed as my greatest common factor for the numerator. So I'm just going to notify that here. The greatest common factor is 3x cubed. All right, so when I take that out, what do I have left inside the parentheses is an x squared in the lead term. I have minus a 6 with a single x, because that would multiply with x cubed to get x fourth. And then a negative 7 multiplies by 3 to get minus 21. And then I've already got the x cubed there. So there is our numerator for the very first step. Let's now take a quick look at the denominator. And again, I hear that guitar sound. There's a greatest common factor here. All right, I see that both leading coefficients are divisible by 2, and I see that both x values, both variables here, have x to the power of 4 or greater. So 2x to the fourth is actually a greatest common factor for the denominator. I'm going to pull that out front, and what am I left with? Well, the lead term just becomes x squared. And the second term here, dividing that by 2, dividing 98 by 2 gets me a minus 49, and I've already got the x4 to the fourth out front. So here we go. We used our greatest common factor strategy to get to this point. Now, let's focus on the numerator again. We're going to use the sum products strategy to further factor this. So let's get we'll keep the 3x cubed out front. And here we've got a quadratic here. And we want to find 2 numbers that multiply to get negative 7, but that add to get negative 6. All right, so 7 and 1 comes to mind to multiply to negative 7. Which one of those needs to be negative here? Well, we're going to focus here because there's a minus 6. We want that 7 to contribute to the minus, and we add by 1. So here, this is how we would factor using the sum product, the numerator. Focusing on the denominator here, we're going to keep that GCF out front. But I recognize here that what we've got right here, this is a difference of squares. All right, so we're going to use our strategy to factor the difference of squares. Remember, difference of squares is when we've got a squared minus b squared. We can factor that as a minus b times a plus b. And here our a value is just x, and our b value is the square root of 49, which is 7. So we can convert this difference of squares here as our a minus b value times our a plus b value. All right, let's go one further step, and we're going to simplify now, because I see that we've got some common factors in both the numerator and the denominator. For instance, we have the x minus 7 in both the numerator and denominator. We can cross that out. And take a look at our terms out front here. A 3x cubed is like 3 with 3 x's. And down in the denominator, we have a 2 with 4 x's. Well, if we wanted to eliminate and x from both the top and bottom, we would be left with 3 over 2x. So let's go ahead and write the 3 over 2x. And also, we're left with the x plus 7 in the denominator and the x plus 1 in the numerator. So this is how I would get this rational expression into its simplest form. Now we're also asked here to state the restrictions on x. What we do there is go back to before we simplified and ask ourselves which values of x will get us a denominator equal to 0, meaning the fraction will be undefined. Well, we've got 3 here. We've got the lead term out here, 2x to the fourth. If x is 0, that term will be 0, and the entire denominator will be 0 as well. This middle term, x minus 7, if x is equal to 7, that middle term will turn to 0. And conversely, an x of negative 7 will get this third term equal to 0. So then x, we can state that the restrictions on x are that x cannot equal 0, 7, negative 7.